Okay, quick talk about how to talk to Arduinos using ones and zeros, which of course we know is digital. And we're not going to get into the coding side of things because the electronic side of things is weird enough as it is without adding in a whole bunch of stuff about programming. So this is going to be just about your circuits. The question that most people ask is, why the heck do you need the resistor? And so that's the question that I'm going to answer today. I'm just going to start by building a really basic switch circuit, the way you might wire it up using an Arduino. Pin 2, digital pin 2. Here's a button. And in your book, they tend to be connecting that button to +5 volts on the Arduino, so that when you press the button, there is a direct connection between pin 2 and 5 volts. Electrons are flowing, and your input on pin 2, when you use digital read, reads high. Yay, great. And then when you let go of the button, you would think that the input would then read low. But what actually happens is all kinds of weird stuff happens. If you do this, try this with the Arduino wired this way, you can actually just sort of touch different parts of the circuit board with your bare hands, and the LED will probably flicker on and off. The input will probably go back and forth between reading high and low. This is because this pin is not low. This pin is, in fact, at this point, what we call floating. It's in an indeterminate state. And sometimes it'll read high, sometimes it'll read low, because it's kind of reading its surroundings, randomness from static electricity nearby. Your hands can change the value. So what we need is we need something that is going to actually make this pin read low, darn it, when the button's not pressed. Here we go, this is great. The pin is now going to read low consistently until we push the button. The problem is when we push the button, now we have electrons that have an equal chance of going high or low. They don't really care which way they go, and they'll probably go both, and we'll end up with the same problem, but this time when the button's pressed. The solution is to count on the fact that electrons are lazy, and they'll only go through a resistor if there's not an easier path to take. So if we stick a nice big 10K resistor here, these electrons at this point, because the button's not pressed, have absolutely nowhere to go but through the resistor to ground. So pin 2 will consistently read low. As soon as we press the button, electrons then run between pin 2 and +5 volts, and they get to the resistor and say, no way, I'm not going there. That's way too difficult. I can take the easy route to +5, and the pin will consistently read high. Now this resistor here has a name. In this case, it's called a pull down resistor. Whoops. Now, not to complicate things too much, but I need to show you another pattern, which is almost exactly the same, but things are reversed. Start a new drawing here. We've got pin 2, we've got a button, and on the other end, what we have is ground. And so this pin will read low when the button's pressed, and otherwise will consistently read high. This resistor is still a 10K resistor, and in this case, it's called a pull up resistor because it's pulling, because it's pulling the pin up to +5, and then when you press the button, the electrons can take the easy route to ground, and the pin will read low. This is also a really common pattern you see, which is why I'm mentioning it here. Often you'll see, you'll be checking to see if something is grounded, and so this is how you'll be doing that. In fact, once you start doing this more and more often, you will want to start taking advantage of the Arduino function when you set your pin mode. Rather than setting the pin to input, you'll often want to try and set the pin to input pull up, which is you'll check the documentation for information about this. But this basically attaches a 10K pull-up resistor to an input pin so that you can build the circuit without actually having to go through the trouble of using a resistor on your board. This is just because it's such a common pattern. I hope that has been helpful.